Aloha and welcome to this screencast where I want to provide you with a walkthrough of the test code that's associated with the robocode-pmj-dacruzer software system, so you get a sense for how that works. So let's, without further ado, get rid of PowerPoint and take a look at Dacruzer. So as you remember, Dacruzer is a, well, you may not know this, I don't know if you've looked at the Dacruzer code, but it's a very simple robot that was actually written by Kimberly Hugh in a previous semester. Thank you, Kimberly, for allowing me to use your code. I also have to say, in Kimberly's defense, that I took out a lot of the complexity of her robot so that I could better illustrate this testing methodology and not clutter it up with her more advanced behaviors that she was providing in her robot for her actual competition. So anyway, this is not representative of Kim's skills as a robocode hacker at all. But the idea of the Dacruzer robot is that it's going to basically cruise around the battlefield, or actually cruise to each corner of the battlefield. So it's going to go to the top left corner, bottom right, top right, and bottom left. And then it's going to go scan for robots and fire. Okay? And then the other thing you'll note about the implementation of this robot is that it has this method here, multiply, which I've just inserted. Doesn't do anything, shouldn't really be there. You can see Eclipse is giving a little warning icon for it. But I have it there because later on in this screencast, when I show you the coverage tool, I want to illustrate what happens when code that isn't executed by or exercised by the test cases, how it shows up in Jacoco. So it's just there for kind of pedagogical purposes. Okay, then we also have some test cases. We have this test Dacruzer versus sitting duck, and then we test the movement, we test the firing, and I want to talk a little bit at this point about the kinds of test cases that you can write for the robocode system, and I'm going to call them acceptance tests and behavioral tests. Okay. Acceptance tests are normally kind of late stage tests that make sure that a system is achieving its basic requirements. And so in the case of robocode, a competitive robot, what's the basic requirement? Well, the basic requirement is that you can beat other robots, right? And so the acceptance test cases in the case of robocode are going to be test cases where you check to make sure that your robot can beat another particular robot, and the test Dacruzer versus sitting duck test is going to be a test to make sure that Dacruzer robot can always beat the sitting duck robot. Okay, so you can imagine if you wanted to beat 6 different robots, crazy, spinbot, etc., you could write a series of 6 test cases, acceptance tests, that test your robot against each of those in turn in a separate test case. And after you think about this for a bit, you'll see that, wow, this is a very powerful approach to development, because what I can do is I can write my 6 test cases, and then I can start tweaking my strategy, okay? And then I can just quickly run my test cases to see whether or not any particular tweak to my strategy is improving my outcomes or not, rather than kind of having to manually bring up, the GUI and set up 6 different battles every single time you make a little change. You might be just changing a little parameter. That's a lot of overhead to check to see how successful or how competitive your robot is. Whereas building a JUnit test case that can run a battle and then tell you whether or not your robot won or not is sweet, right? You can fiddle around with your strategy, run your test cases, see whether or not your robot is beating other robots or not, and then go from there. So that's an acceptance test case, very powerful. The other kind of test case that we'll look at is what I'm going to call behavioral test cases. In the case of robocode, the idea is that we want to be able to test to make sure whatever strategy we thought we were implementing via our code is actually being implemented. So in the case of Dacruzer, one of the strategies that we're implementing is that we visit all 4 corners of the battlefield. Okay? And so we're going to write a behavioral test called test Dacruzer movement, which checks to make sure that our robot actually succeeds in doing that when it cruises around. Okay, so acceptance tests, behavioral tests, what we're going to do. All right, the way that we implement test cases in robocode is we're going to write a class that extends robot testbed. And that class implements a bunch of different methods which enables you to easily set up a battle, specify the set of robots in the battle, run the battle, and then query the results. Okay? So we look through this particular piece of code. We're going to extend robot testbed, which means that we override a set of methods to customize, we're going to create a customized class, a subclass of robot testbed, where the overridden methods are going to specify the particular testing behavior that we need for this particular test case. Okay, so it's super critical that you include these overrides to ensure that you're actually spelling the name, getting the return values and everything all correct, so that you're actually overriding this method of this superclass. So the first method, called getRobotNames, specifies the names, and the ordering is important, as you'll see a little bit later. So we're going to specify that we're going to have the sitting duck robot and the PMJ-dacruzer robot. You always have to have at least 2 robots in a battle. Okay, so we've got to specify at least 2 names here. And then there's another method which we override called getNumRounds, which returns how many rounds we want to do in the battle. I think the default is actually just 1 round, but that doesn't give you a good sense about how your robot would work against more complicated robots, because of course, depending on initial position and so forth, things could go differently. So we're going to specify 10 rounds as being a reasonable number of rounds with which to get a sense for whether or not a robot can reliably beat another robot or not. Okay, then we have this onBattleCompleted method, okay, which is called once after the battle's over, okay, and we get this object called a BattleCompleted event, which is an object that has a lot of state associated with it, which we can query in order to find out what the heck happened. Okay, so we get this this event object we call getIndexedResults, and that returns an array of battle results objects, okay? And it turns out that the order in which these so there's one battle results object per robot that participated in the battle, and the order in which the results are listed in this array depends upon the order in which the robots are listed up here. So the 0th element, okay, or I should say the first element, which is at array index 0, is going to be results for sitting duck, and then at array index 1, because it's 0 based, will be our robot stuff. Okay, so the first thing I'm going to do is I'm going to get the element, the object at index location 1, second element, but the array index 1 of the battle results array. That's our Dacruzer results. And the first thing I'm going to do is basically just a sanity check to make sure I haven't somehow messed up, with my array index. So I get the name of the robot, and I check to make sure it's actually PMJ-dacruzer star, because it turns out this is a development robot, so the robocode system appends an asterisk to the end of it. So that's just making sure that we did this, this element retrieval correctly. Then what we do is we find out how many rounds that the Dacruzer robot won, and we're going to compare this to the total number of rounds in the system, and they better be equal, because we want Dacruzer to always win against the sitting duck robot. Okay, and so it turns out that, and so this test case will pass if if that happened. Now I'm going to also show you some other events which I'm supplying here just so you see the kinds of things that you can also check for. There's other things you can look up in battle results. You can check the Java docs for that. But there's other methods of this robot testbed that you can override, such as the onTurnEnded event, the onTurnEnded method, which is called after every turn, and you've got this event object, this turnEnded event, which you can query to find out various state variables and check things about what's happening during each turn. There's a getInitialPositions method, which you can override in order to specify exactly where every robot participating in the battle should start. Okay, by default, they're going to be randomly picked, but you can override that if you want to change it. I didn't want to override it. The other thing you can do is decide whether or not, if you do 10 battles, okay, even though the initial positions might be randomly picked, they'll be the same randomly picked positions every time the battles run. And if you don't like that behavior, you can make this return false. But we like that behavior, so we're going to keep it true. Sometimes you think there should be errors thrown, and in that case, you can check to see what the errors were. And then if you want to run some code either before or after your battle begins, you can override these methods. Okay? So that's the simple acceptance test unit test, and those are super simple to write. I mean, there's no reason not to write these because they're almost trivial. Okay, and if you're writing your own, you should not include these empty methods. Right, get rid of them. I'm just supplying them here so you can see, right, that they exist. But in your code, if you're not going to override them to a different value, you should omit them. Okay, so that people aren't confused. Now let's look at a behavioral test. This is the test-dacruzer movement behavioral test. And what you can see, the way this is going to work, we're going to have the same sitting duck and dacruzer robots in the same order. We're going to have the same number of rounds. And we got these booleans, visited upper left, upper right, lower left, lower right, that we're going to initialize to false. And now we're going to override that on-turn-ended event, which I talked about in the last test case. Because what we're going to do is we're going to check to see the position of the dacruzer robot at the end of every turn. Okay, and the way we do that is we know that dacruzer is the #1 element of that array, and so we get this we get a get turn snapshot of that particular robot. So that returns this snapshot object, and from that we can find out what its x and y position is. Okay, then what we're going to do is we're going to check. We're basically going to establish a 40 pixel square in the top left, top right, lower left, lower right corners, and we're going to check to see whether or not our robot's position is within that 40 pixel square after each turn. Okay, and if it's in one of those squares, any one of those squares at the corners, we're going to set my boolean, one of these, the appropriate boolean, to be true. Okay, and then when the battle is completed, we're going to assert that all of those booleans are actually true. And we could have made actually like a logical condition, just ANDed all these things together. And then, that would have been one line. Then kind of the nice thing about doing it as 4 separate assertions is that the one that fails is going to tell you exactly which corner, at least the first corner, that wasn't visited. Whereas if we ANDed them all together, we'd only find out that one corner was not visited, but we wouldn't know which one it was. So it's a little more verbose, but it's a little more diagnostic. Okay? Okay, so the other thing to note is that even though we've got 10 rounds in our battle, we don't reset, the on-turn ended is going to be called after every turn of every round. So we don't necessarily know that the robot visited all 4 corners in every single round of the 10 rounds. That this test doesn't test for that. You could test for that by finding out what the round number is and having some array of these booleans or whatever. But in fact, for this particular behavior, it's not necessarily bad that it doesn't visit all 4 corners, because for example, maybe it can kill the sitting duck robot even before it gets to all 4 corners. Okay, so anyway, that but just to let you know that this on turn ended is going to be called repeatedly over all the rounds, and you're not you're going to get kind of the aggregation of its behavior over all of the rounds and not just a single round. Okay, so that's how that works. I'll leave it. You can look at the firing method. This is another behavioral test, and you can just read through that code yourself. They all, it should be pretty self-explanatory at this point. So now let's actually run JUnit and see what happens. So I'll say ant -f JUnit. The other thing I've got to make sure, I see this in class and it just surprises me, all you people who are actually typing out the full names of these build classes. I want to tell you a secret. The tab key. Tab key, very important in software development. Very bad if you're inserting tabs in files, but the command line, you should be typing the tab key more frequently than any other key, in my humble opinion. So when I run the build system, I just type out enough of that build file name like this to make it unambiguous, then I press tab, get the whole thing. That way it's spelled correctly. Sometimes I'll press tab and nothing will happen and I'll realize I'm not even in the right directory. That's, much faster than typing the whole darn thing out and then having something crazy happen because I couldn't kind of find the file. So definitely get used to the tab key. If you've got some kind of command shell where the tab key's not working, fix it. Okay? You got a lot of weeks left in this class. You'll save yourself typing thousands, if not tens of thousands of characters over the next couple of months if you get your tab key to work correctly in the command shell. So please do that. All right, so anyway, typing return. Here we go. Unit tests are running. Okay, that's one of those rounds. Okay, 10 rounds. The first one was for 20 rounds. That's probably that first behavioral test I didn't go over. The last two, 10 rounds. Those are the behavioral and acceptance test. Build successful. Everything looks good. But you're saying to yourself, well, I don't really know necessarily what happened. Maybe I don't believe that the build was successful. You never know these things for sure. So let me show you how you actually look at the results of a unit test. Go in the build directory. Go in the JUnit directory. Okay? And this works if you've typed ant -f junit.build.xml. Now the verify task doesn't necessarily build this nice report that I'm about to show you. So in order to get the nice report, you run ant -f junit.build.xml. Go in there, type, double-click index.html, and what you get is the following. You get this nice kind of 3-pane layout, shows you all the tests that were run, okay? And then you can click on the test, and you can see, there was an interior, method called run, and its status was success. You can even click on these things and, find out more if you want, but that's only kind of for debugging. Okay, so we can see if any of the tests had failed, we would have had a summary here. We'd have seen that there was failures or errors, but in this case, all of the tests pass, so we're all good. Okay. Now there's another tool which we can run, which will give us the coverage of our test cases, and that's called Jacoco. And so we can say ant -f javadoc, right? That's another one. So we have to JAC, and now it's disambiguated. We get Jacoco. Type return, and this is a pretty cool coverage tool. What it does is it actually instruments the bytecode. So you have to compile. It compiles the system first, then it injects bytecodes into your class files, so that as those classes execute during the running of your test cases, some coverage level information is going to be output. And then that coverage information is fed into a reporting tool which tells you your results. Okay, so we have to now go to the build directory, and then we go to the Jacoco subdirectory, and then we go to the report subdirectory, double-click index.html, and we get this interesting little visualization of our coverage results. And what you can see is our coverage is only 99%. Okay, and so you might be asking yourself, oh, I wonder what I missed. Okay, you double-click on the package, and then you get a listing of all the classes in the PMJ package, and we can see they're all, there are 3 of them are 100%, indicating that we covered all those things. But then there's this one class, Dacruzer, where there's a little bit of red indicating a missed instruction. So let's go down here, and what we can see here is that the run, on, scan, robot, and Dacruzer classes all had 100% coverage, and you can see via the little bar kind of the relative number of lines. Okay, but there's this multiply method which had 0% coverage. So let's click that, and that takes us right into a colorized version of the source code, which is pretty nifty. Thank you, Jacoco, for doing that. And what you can see is that if there's a line of code that is outlined in green, it was executed during the test case. And if there's a line of code right at the bottom here, you can see the multiply method that has red outline indicating that it was not executed. Okay, so that multiply method, as I told you at the beginning of this lecture, was not, I put it in there intentionally just so I could show you what an uncovered method looks like in Jacoco. But of course we wouldn't have that in a method in this system in practice because it's not actually doing anything. However, you may find when you run test cases over your own system that there's actual functional code which is called that your test cases don't exercise, and then you've got to think about what it is you should do. Okay, the last thing a couple other things I want to mention. There's another kind of test which you can choose to write as part of the system. We've talked about acceptance and behavioral tests. The third kind of test is called a unit test. And the unit tests are useful when you have small self-contained classes that perform some function that you want to test in isolation. So for example, you might have some trigonometry classes, or utility methods that do some kind of trigonometric conversions, but that help you do firing or positioning. And so you might want to write some tests which simply check to make sure that your trigonometry calculations are correct. And so there you'd have like well-defined input and outputs. You could write a little test for just that particular behavior. That would constitute a unit test. It's not really behavioral because you're not looking at the strategies. It's certainly not a acceptance test because you're not testing against the testing to see whether your robot can beat another robot. It's a very fine-grained test. Okay, and so whether or not you have unit tests in this particular scenario is just basically a function of whether you need them. If you have these kind of utility methods which you can test in isolation. And that's very useful to do because if you have a trigonometry calculation that's not working correctly, then it may be very hard to see why it is that you're not beating robots or why your behaviors are not actually working out the way they should. Okay? So, having these fine-grained tests that test one little component of the system at once can be very useful to you in terms of speeding up development because it's all about developing things fast. Okay, I want to emphasize that. You may feel like, writing this build system and writing these test cases, man, this is taking me so many extra hours. But the reality is, for a system of any lifespan, okay, the whole goal of these things is to actually make you work faster than you could before. Okay. Last thing I want to mention is the very danger with this coverage tool, as I talked about in the last lecture. The danger with coverage is it's very addictive and it can give you a false sense of security. So you could look at this multiply method and go, well, I'll just write a test that checks to see that that the multiply method is called, and then I'm all good. I've covered all my methods, and that's exactly how should I call it? The Achilles heel of coverage tools, which is that they lull you into the sense that merely by getting things to be executed, you've provided good test cases. It's not the case. Particularly when all you're trying to do is make all the lines green, you're likely to write test cases that don't actually do anything to help you discover bugs. They simply, make sure that the lines are executed in a kind of not interesting way. Okay? So I really want to encourage you to think about, write your acceptance tests, write your behavioral tests, check your coverage based upon that, and if it's not good, then ask yourself, what am I not thinking about, okay, with respect to behavior or acceptance, and then move on from there. Okay? All right, hope you enjoyed this, and I'll see you next time.